All right, so lecture 14, quadratic functions. Okay. So after this lecture, hopefully you could be able to distinguish. So after this lecture, hopefully you could be able to distinguish quadratic expression, quadratic equation, and quadratic functions. And from the quadratic functions, we're going to learn how to identify vertex, axis of symmetry, and a lot of things that related to quadratic functions. Okay. And at the end, you're going to collect all of the information related to quadratic functions, and you're going to graph the quadratic function without a calculator. Cool. No? Okay. Do you know that I don't have a calculator until I come to the States when I was 21 years old? I didn't have a phone until I was 21 years old. Yeah. You can do a lot of things just by learning algebraic process of that. But good. Cool. 20 years ago. Not cool right now. All right. So, all right. So one of the application that you probably see almost every day is, when you throw a pin up in the air, or you throw something up in the air. Look at this, right? You have the motions. That's the projectile motions. Something like this can be described using the quadratic equation, quadratic functions. And you're going to see a lot of this motion of this application in physics. Right? If you take physics, general physics one in anywhere in the world, you could probably see this motion, and this can be described using the quadratic equation, quadratic function. All right, so quadratic functions. So a quadratic function is of the form f of x equal to ax squared plus bx plus c. So I want to impose one condition that a has to be different from 0. Now, when a is equal to 0, what type of functions do we have? Linear functions, right? So therefore, you have to impose this condition, a is different from 0. Otherwise, we have the linear functions, then there's nothing for us to do. So if you just take out the part of ax squared plus bx plus c, we call that the quadratic expressions. Now, if you just look at ax squared, this is called the quadratic term or the leading term. Leading term because this contains the variable x with the highest degree among all the terms in the expressions. The quadratic term because again this contains square. The next term, dx, is just the linear term. Linear because x raised to the first. And c by itself without any variable attached to it, or more specifically, I could say that c by itself is actually equal to c times x raised to the 0 power. Okay. Anytime you see a constant by itself, usually it means that that constant multiplied with a variable but raised to the 0 power. Okay. So in this case, we call c by itself is a constant term. And the graph of a quadratic function is called parabola. So there are two types of parabola. That one is open upward when you have the leading coefficients here to be positive, and the parabola open downward when you have the leading coefficients. Next definition, so vertex. It's just a fancy word to say that is the turning point of the parabola. Depends on the value of the leading coefficient A, you will have a different vertex, right? If A is positive, that means you have the parabola open upward, minimum. When A is less than 0, you have the parabola open downward and you have the vertex to be in maximum. So when A is greater than 0, parabola opens upward, vertex is a minimum. When A is less than 0, the parabola opens downward. Vertex is a maximum. So in calculus 1, you will learn a technique how to actually calculate a maximum value or maximum point and minimum value or minimum point algebra and precisely calculate the maximum and minimum value through some process called derivative. However, that's for calculus 1. In pre-calculus, unfortunately, we don't have that technique. So to calculate the maximum value and minimum value parabola, we give you the vertex formula. Unfortunately, this is where I asked you to learn, but we don't yet learn the technique to derive the formula. Okay. So, but hopefully it's not too difficult for us to memorize this. The vertex formula is just a point to calculate the maximum and minimum. So negative b over 2a is the first component or the x component. Negative b over 2a. Or basically, you just memorize the x value. Now, the y value is whatever x value you have, you substitute into the quadratic function. All right, so the y value is f of negative b over 2a. With me on that? Okay, just the x value, just negative b over 2a. And you have the x value, substitute that into the quadratic functions and get the y value. Then the vertex. You're okay with that? Now, next for axis of symmetry. So this axis of symmetry goes through the vertex. This is basically a vertical line that goes through the vertex. So axis of symmetry is the vertical line. passing through the vertex. Now, because this is a vertical line that is going through the vertex, so therefore, when it's a vertical line, this is always going to be equal to x equal to negative b over 2a. Does that make sense to you? Okay. X equal to indicate vertical line. Because it goes through the vertex, so x value is equal to negative b. So the vertex, the axis of symmetry is always going to be x equal to negative b over 2a. When you do an online homework, this probably not going to be the problem because they set everything up for you, but in the written exam, in quiz, when you indicate axis of symmetry, can you please indicate x equal to a number? If you give me just a number, it doesn't mean anything. There's no context to that. So write something to explain the answer. Just a little bit, just a few minutes. So the axis of symmetry is x equal to a number. Tell me a story. We good? Any questions? All right. That's it. That's it for quadratic function. That's all the information that you need about quadratic function. Awesome. Good. Awesome. All right. All right. So let's do something. Don't go. All right. So given this function f of x equal to x squared minus 6x plus 8, what we're going to do in this example is that we're going to graph this quadratic functions with our calculator. I know we have calculator and whatnot, machine, computers, but can you, given this, abstract equations, can you understand that better? So does the function open upward or down? So is this parabola open upward or downward? You know it, and I know you know it. How would you identify if a parabola open upward or down? What negative in front? If there were. In front of what? X squared, right? So you want to look at the value in front of x squared. So what is the value in front of x squared? Positive one. So therefore, the parabola open upward or down. There you go. So you analyze the problem, right? So this parabola open upward. Why that is the case? Because a is equal to 1, which is positive. Now at this point, can you calculate the y-intercept? With ease, right? When you say y-intercept, what is x value equal to? 0, right? So y-intercept x equal to 0, so y equal to 0 square minus 6 times 0 plus 8 equal to 8. So the y-intercept is 0.8. Now, next, you know how to find the x-intercept. Yes, right. X-intercept, that means y equals to 0. Okay, so the output is equal to 0, or x squared minus 6x plus 8 equal to 0. You can factor this equations, right? So you get x minus 4, x minus 2 equal to 0. So there are two values, two solution, or two x-intercepts. X equal to 2, x equal to 4. And you conclude that x-intercepts are 2, 0 and 4, 0. All right. Part D, you want to calculate the vertex of this parabola. All right. So again, you need to use the vertex formula, and I need you to memorize that. Shouldn't be too difficult, I hope. That the vertex formula is equal to negative b over 2a, comma f of negative b over 2a. That's the formula. Now let's go back to the original functions. Can you please tell me what is a equal to? So in this case, a is equal to 1. What is b equal to, and what is c equal to, for good measure? What is b equal to? Negative 6. What is c equal to? 8, right? So b is equal to negative 6, c is equal to 8. So the x value of the vertex is negative b over 2a. Given that negative b is equal to negative 6 over 2 times 1. So what is x equal to? Positive 3. Now with the x value of the vertex, you substitute back into the original functions to find the y value of the vertex. So y is equal to 3 square minus 6 times 3 plus 8. Do a quick calculation, please. What is y equal to? Negative, less than that, or more than that. Negative 1. Should be negative 1. So I have positive 9 minus negative 8 minus 18 plus 8 should be negative 1. So the vertex is three comma negative 1. Is this vertex a maximum or a minimum? Minimum. Again, because you have a parabola that opens upward. So this should be a minimum. Now, what is the axis of symmetry? X equal to? There you go. So the axis of symmetry is x equal to 3. So lecture 14 is about quadratic functions, right? So quadratic function is the function of the form ax squared plus bx plus c. And we need to impose the conditions that a is different from 0. Otherwise, when a is equal to 0, then you obtain a linear function back. So we don't want that, right? So quadratic functions, we learned a few things, right? We learned that the graph of the quadratic function is a parabola. There are two kinds of parabola that open upward when the leading term or the leading coefficient is positive, when a is positive, and the parabola open up downwards when a is negative. You have the vertex, which is the turning point of the parabola. The turning point means the maximum or minimum. So in this case, the vertex is the maximum when the parabola is open. Sorry, the minimum when the parabola opens upward is positive. When A is negative, parabola opens downward, then you have a maximum. You have a vertex formula. Again, I mentioned yesterday that one you may have to memorize it. That is the x component is negative b over 2a. When you get the x component, substitute back into the original functions to get the y value. And then the last concept that we touch on is the axis of symmetry, which is the vertical line that passes through the vertex. Because the vertical line passing through the vertex, the axis of symmetry is always going to be x equal to b over 2a, which is just equal to the first component of the vertex. We toward the end of yesterday, we covered the first two questions of example 1. So in this example, you are given a function f of x equal to x squared minus 6x plus 8. And we say that this is going to be a parabola that open upward because a is equal to 1 is the positive number. We found the y-intercept, we found the x-intercept, we found the vertex, and we determined that the vertex is a minimum in this case, again, because the parabola is open upward. And we say that the axis of symmetry is x, is that of x equal to 3. Again, the axis of symmetry is the vertical line that goes through the vertex. All right, so let's continue with G and H. So for G, they ask you to sketch the functions and you label the vertex, the intercepts, and also the axis of symmetry on the graph. Okay, so we're going to use all the informations that we already answered from the previous part and put into the graph so we can sketch the parabola. So first thing first, the vertex, in this case, a minimum, right? So the vertex is 3, negative 1. So 3x equal to 3, y equal to negative 1. So this is the vertex right there. You have the y-intercept, which is 0, 8. 0, 8 right here. This is the y-intercept. You have two x-intercepts, 2, 0, and 4, 0. So x-intercepts here. All right. Now can you also put in the axis of symmetry, in this case, x equal to 3. Right, so anyone has a ruler that I can borrow? Ruler. Where did you get the ruler? Thank you. All right, can you put in okay, so that is the axis of symmetry, that vertical line going through the vertex. So let's connect the points together to create or sketch out the parabola. Right. All right, so remember you have x equal to 3 is the axis of symmetry. Right, on the left-hand side, you have one point that is the y-intercept. Now, that point can be reflected over the axis of symmetry. So this point from here, you can reflect it over to the axis of symmetry to allow you to draw all the side of the parabola. So that, okay. So let's label them. Here you have the vertex. You have the x-intercepts. You have this one is the y-intercept. Right. And you have the axis of symmetry. In this case, x equal to 3. So hopefully this example will give you some idea how to do some analysis on certain problems. So in this case, you have a quadratic functions. Now you analyze the quadratic functions to actually draw or sketch the graph of the quadratic functions. Okay. Now let's cover one more. Sorry, any questions on example one? This example. Good. All right, so we have the last part here. What is the domain and range of the functions? So the domain of the function is from negative infinity to positive infinity. And what is the range of the functions? So from -1 to positive infinity. All right, any questions? Okay, good. So now let's move on to example 2. Consider the functions f of x equal to -2 times x squared minus ax minus 6. Okay, so is this function, this graph open upward or downward? Downward, right? Why that is the case? Because a is equal to -2, which is a negative number. Why a is equal to -2 less than 0. Now, what is the y-intercept? Again, x equal to 0 when you find the y-intercept. So y is equal to -2 times 0 square minus 8 times 0 minus 6 equal to -6. So the y-intercept is 0, -6. For x-intercept, y equal to 0. So you set -2x squared minus ax minus 6 equal to 0. All right, so at this point, you know how to factor the quadratic function or quadratic equations, right? But before doing factorizations, let's reduce this equation a little bit by dividing both sides for -2. So when you divide both sides for -2, you got x squared plus 4x minus 3 equal to 0. So again, from one step to another, what I did is I divided both sides for -2. And now I factor the left-hand side of the equations. What factor should I get here? Positive, thank you. Thank you. So what factor should I get here? And 3 and 1, yes. So x plus 3, x plus 1 equal to 0. So you're going to obtain two x-intercepts. All right, so x equal to -3, x equal to -1. So x-intercepts are -3, 0 and -1, 0. So the next part is to find the vertex. Am I moving too fast? Good. Next part is to find the vertex. All right, so the vertex formula is negative b over 2a, comma, f of negative b over 2a. Again, you just need to memorize the first component of the point, right? Negative b over 2a. When you get the x value, substitute back into the original functions to find the y value. So the vertex, right? So here you got a equal to negative 2, b is equal to negative a, and c equal to negative 6. So x equal to negative b over 2a, or negative of, so b is negative 8 over 2 times negative 2. What is this equal to? What is x equal to? Negative negative 2, yes. Instead of positive. So negative a, negative 2. So the negative, this two negative cancel out, and you're left with the negative in front. So you got negative 2 here. X is equal to negative 2. Yes. Good. Now for the y value, you substitute x back into the original functions. So you got negative 2 times negative 2 square minus 8 times negative 2 minus 6. What is y equal to? Should be a very nice number. What do you get? 2, positive 2. So the vertex is negative 2, comma, positive 2. Is the vertex maximum or minimum? Maximum, yes. What is the axis of symmetry? X equal to negative 2. All right, now you have all the necessary information to sketch the graph of the parabola. Start with the vertex. So x equal to negative 2, y equal to 2. That's the vertex. You have the y-intercept, x equal to 0, y equal to negative 6. That's another point. You have two x-intercepts, negative 3, 0, and negative 1, 0. So two x-intercepts. And you have the axis of symmetry, which is x equal to negative 2. Okay. Now let's connect the points together. And here you utilize the axis of symmetry to reflect this point over the axis of symmetry, which give you this point. Okay. Then can you label them? All right, so you have here the vertex. Right. This is the y-intercept. It's the x-intercept. Then you have the axis subsymmetry. X equal to 3. Sorry. X equal to -2. Any questions? Okay. Um, let's cover the last problem here. What are the domain and range of the function? So the domain of the function is from -infinity to +infinity. Now, what is the range of the functions? So -infinity to 2, including the 2. Question? Any questions? All right, so let's move on to a zero of a function. So we wrote that definitions of the zero of the functions earlier, right, in another lecture already, right, a few lectures ago. Now let's just write it down again. So a zero of a function. So a zero of a function is an input value or x value such that f of x equal to 0. So in addition to having the name zero, there are other names that you can use to describe this zero. You can use the word solution, you can use the terminology root of the equations, you can use x-intercept of the graph of the function. They carry the same name. Okay. All right, so a solutions, sorry, the zero can also be described as the solutions of the equations f of x equal to 0 or the roots of the equations f of x equal to 0 on the x-intercept of the graph of the functions y equal to f of x. So I'm aware that many of you have seen this materials before, but we have a few different ways to obtain the solutions of the quadratic equations, right? one that we have done in the last two examples, that is factor the quadratic equations that equal to zero and you solve the solutions. Another way to solve the solution of the quadratic equation is use the something called the quadratic formula, which we're going to cover in a few minutes. Okay. But here, in this example, we want to find the zero of the functions by factoring the quadratic expressions. Okay. So to find the zero of the function, you set the function like x squared minus 16 equal to 0. And you can factor this, right? So x squared minus 16 is the difference of 2 squared. So you can do x minus 4, x plus 4 equal to 0. So you get x equal to 4, x equal to negative 4. So you have two zeros or two solutions or two roots. Okay. Another way that you can find the solution of the equations is that you move negative 16 to the right-hand side and then take the square root on both sides of the equation. That's another way that you can cover, although that is not a factoring method, but that's another way to do it. So I'm going to write on the kind of like the right-hand column here. So 16 x squared minus 16 equal to 0. Or you do x squared equal to 16. And then you take the square root on both sides of the equation and you got plus and minus 4. Any questions on that? All right. So remember, when you do equation, when you take the square root of the equation, you're supposed to have plus and minus back. Take the square root. All right. Moving on to the next example, you have the function of the form x minus 2 altogether square minus 16. You set this equation function equal to 0 to find the zeros. Okay, so x minus 2 square minus 16 equal to 0. You can apply the same thing. This is a difference of 2 square. So that's one approach. That allows you to factor the left-hand side. Another approach is to move negative 16 to the right-hand side and then take the square root on both sides of the equation. All right, so let me cover the first method. So x minus 2 minus 4 times x minus 2 plus 4 equal to 0. Right, so again, for this method, we factor using a difference of 2 squares. So here you get x minus 6 times x plus 2 equal to 0. So you get x equal to 6 or x equal to negative 2. Again, there's another approach that you can do. That is to move negative 16 to the right-hand side. You get x minus 2 square equal to positive 16. And then you take the square root on both sides of the equations. You get plus or minus 4. Now, when you get plus 4 or minus 4, you can solve two equations simultaneously. All right, so here you get x minus 2 equal to positive 4. Here you have x minus 2 equal to negative 4, and you can solve for x. So x equal to 6, and here x equal to negative 2. All right, In part C, can you do part C by yourself, please? When you're done with part C, can you move on to the next example as well? So in the quiz or in the test, you don't have to give me two different methods here. You use whatever method you feel comfortable. When you've done with C, can you move on to the next example as well? It's the same approach, similar questions. Right, for C, you can use the difference of two squared to factor expression. Too easy? Little bit? All right. So for C, you do so 3x minus 2 square minus 36 equal to 0. Again, here you can use difference of two squares. So you do 3x minus 2 minus 6 times 3x minus 2 plus 6 equal to 0. Or you get 3x minus 8 times 3x plus 4 equal to 0. So there are going to be two solutions here. X is equal to 8 over 3, or x is equal to negative 4 over 3. Good. All right, so that's that is this problem. Let me move on to the next example. You also find the zero of the functions. Very similar. Yes.
Oh, how come 8/3 is positive?
So if you solve it down, right? So 3x minus a equal to 0,
Okay.
you move negative 8 over. So 3x equal to 8, or x equal to 8 over 3. So that's why. Good. Questions? Concerns? All right. So next example, you find the zero of the following functions. So here you have x squared minus 5x minus 6 equal to 0. You can factor the left-hand side. You get x equal to negative 6, x minus 6 times x plus 1 equal to 0. Or you get x equal to 6, x equal to negative 1. Okay. For the next example, you get x times x minus 4 minus 12 equal to 0. So what you do for this problem is you expand x times x minus 4 and you factor it together. So here you have x squared minus 4x minus 12 equal to 0. Now you factor the left-hand side of the equations. You get x minus 6 times x plus 2 equal to 0. So you get x equal to 6, x equal to negative 2. What time do we go? 1:20? All right, so we still have time. The last example, you get x times x plus 8 plus 12 equal to 0. Now you get x squared plus ax plus 12 equal to 0. All right. You factor the left-hand side, you get x plus 6 times x plus 2 equal to 0. So you get x equal to negative 6, or x equal to negative 2. Now, for the last part of this lecture notes, we can find the solution of the quadratic equation using the quadratic formula. How many of you have seen this formula? Yeah, so most of you, right? So the quadratic formula is x equal to negative b plus and minus square root of b squared minus 4ac divided by 2a. All right, so the solution of the quadratic equation can be found using the quadratic formula. And there can be two real solutions, one solutions or no real solutions, depend on the value of b squared minus 4ac. Because we need to impose the conditions that this expression under the square root has to be greater than or equal to 0. And that part, b squared minus 4ac in mathematics is called the discriminant and usually denoted as delta equal to b squared minus 4ac. So when delta is positive, you obtain two real solutions, two real distinct solutions. When delta is equal to 0, you have one solution. And when delta is less than 0, there's no real solutions. We don't cover complex numbers in this course because it's too complex. Get it? Yeah. Okay. All right, so I'm doing research in applied mathematics, and there's one part of applied mathematics called pattern formations that you can actually write down a formula, a mathematical formula to describe the spot and stripe on animals, which is fascinating. And one of the analysis related to that, this experiment, it's fascinating. But yeah, that's it. It's very analysis, but part of the analysis involved b squared minus 4ac. All right. So this quadratic formula is extremely helpful to solve for the solution of the quadratic equation when you cannot do in factor or move things around or manipulate the quadratic equation at all. For example, we have the following problems that we can do. Given the function 3x squared minus 5x plus 1, if you want to find the solution of this equation, it's extremely hard to do using factoring method. So therefore, what you can do is you just solve this equation using the quadratic formula. So you set this equal to 0, and you define that a equal to 3, b equal to -5, and c is equal to +1. So now you use the quadratic formula. So negative b plus and minus square root of b squared minus 4ac over 2a. You got -5 plus and minus square root of -5 squared minus 4 times 3 times 1 altogether divided by 2 times 3. Can you calculate what is the discriminant equal to? 13, yes. All right, so the number under the square root should be 13, positive 13. So here you got -5 plus and minus square root of 13 over 6. All right, and just leave it like that. Right. Because we're not going to use calculator to describe square root of 13. Yes, positive, yes. So negative and negative. Thank you. So this should be +5. All right. So similar to that, can we do the next example? So set this equal to 0 and define a to be 3, b to be equal to -4, and c is equal to 2. All right. X is equal to -b plus and minus square root of b squared minus 4ac divided by 2a. Well, that is negative of -4 plus and minus square root of negative 4 squared minus 4 times 3 times 2 all together divided by 2 times 3. So now can you calculate the number in the square root? What's that equal to? Negative 24. What do you get? Negative 8. So it's negative 8. It should be a negative number anyway, but negative 8. So if you calculate the number under the square root, which is the discriminant, you should get negative 8. All right. So in this case, the discriminant is negative 4 squared minus 4 times 3 times 2 and give you negative 8 less than 0. Because of this, you can automatically conclude that there are no real solutions. So here, conclude no real solutions. And for C, very similar approach. Set that equal to 0 and you get A equal to 4, B equal to 20, and C is equal to 25. And you solve for X, you get negative B plus and minus square root of B squared minus 4AC over 2 times A. Or this is negative 20 plus and minus square root of 20 square minus 4 times 25 altogether divided by 2 times 4. So now again, can you quickly calculate the number in the square root? Give you a very nice number. Zero. So the number under the square root should be 0. So therefore you get X equal to negative 20 over 8. And try to simplify as much as you can. This is a very simple number to simplify. So you should have negative 5 over 2. So here, because the discriminant is equal to 0, you only have one. Good. All right, so we're running out of time. The last problem should be easy, very similar to the last three that we covered. So I'm going to leave it to you to do. So we're done with lecture 14. We're going to move on to lecture 15 tomorrow. Okay. Thank you for being here, everyone. I'll see you tomorrow. Have a good day.